What's up, class? Alright, so today we're going to be talking about complex numbers. Now, complex numbers is also known as imaginary numbers. Imaginary number, to me at least, is anything that is not a real number. So, let me find my pen real quick. Let's look at the board real quick. So this is a this is a real number. This is a real number. This is a real number. This is also a real number. This is a real number. Now, what about this? What about this? Is this a real number or an imaginary number? You might be tempted to say this is a real number, but fun fact, this is an imaginary number. Now, in math, we're always told that we cannot take the square root of a negative. And for the longest of times, we were told that this is undefined. Now, let's actually try to solve this. There's a rule in math that states that the square root of -1 is equal to I. Okay, it turns out that all the years we can take a square root of a negative. So, I is equal to the square root of -1. Okay, now what if you have I squared? Does anybody know what the answer is to this? I squared will give you a -1, simply -1. I cubed will give you 1. I cubed will give you 1. We can also use this to solve actual math problems. So let's say like the square root of -9. Let's actually go ahead and rewrite this. So the square root of -9 could be written as the square root of 9 times the square root of -1. So the square root of 9 is 3. The square root of -1 is I. So the square root of -9 will give you 3i. Now we can also do the square root of, say, square root of -16, which we know it'll come out to the square root of 16 times the square root of -1. Square root of 16 is 4. And square root of -1 is I. So square root of 16 will give you 4i. Okay. Alright guys, now let's do a couple addition problems. Well, one addition problem. So we're going to use 5 plus 8i plus 1 minus 5i, parentheses go here. We got 5 plus 8i plus 1 minus 5i. Now the first step to solve this is going to be to remove the parentheses. So first step is to remove the parentheses. So now we got 5 plus 8i plus 1 minus 5i. Now the next step, we will take everything that's together. So it'll be like 5 plus 1. And then we have 8i minus 5i. But what we're going to do, we're going to take only the 8 and the 5. And we're going to leave the I off by itself. So it's going to be plus, because these are both complex already. So since these are both complex, we could combine them together. So 8 minus 5 and then I. Now the next step is going to be to combine everything. So 5, so that becomes 6. And it's 5, that becomes 3. Plus 3. Now we get 9. Now we have 9i. Now fun fact, how would you guys rewrite 9i? So that'd be 9 times square root of -1. So that's like 9 square root of -1. It's the same thing as 9i. Fun fact, just a fun fact. Alright guys, now that we got adding complex numbers, it's time that we move on to multiplying complex numbers. Now, you guys know, like, it's like, let's say you have something like this, right? 2 times 4 plus 5. So we could use like the distributive property where we just distribute this to each term. So you know it becomes 8 plus 10, 18. Okay. Now we also have what's called the FOIL method. Now if you guys know what FOIL is basically 2 plus, let's say, x times what can I, 2 plus x times 1 plus 3. Okay, so then FOIL will be first, and then outer last. You guys know this already, so it become 2 plus 6 plus x plus 3x. Okay, so 8 plus 4x, right? So that's basically the FOIL method. Those same two methods also apply to complex numbers. So let's say we had the problem 2 times 3 plus 4i. Now for this one, we would use the distributive property. So we have 2 times 3 equal to 6. 2 times 4i is going to be plus 8i. Now 6 plus 8i, we would actually leave it just like that. This will be our final answer. Like you guys see right here, we only have one term being multiplied by a factor. So it's not like two factors completely. So now let's say we have two factors. In this situation, we will have to use the FOIL method. Now let's say we have 4 minus I times 6 plus, let's say, 2i. Now make note of this rule right here where we said I is equal to the square root of -1, and then I squared is going to be equal to -1, right? Because if we square this and we square this, we'll essentially get rid of this by squaring this. If we square this, we get rid of it. So it only becomes -1. So I squared is going to be equal to -1. Now let's use FOIL to try to multiply this. So 4 times 6, we're going to get 24. 4 times 2i, we're going to get plus 8i. Now we got now we got I times 6 is going to be minus 6i. Since this is a minus, or down here has to be a minus also. Now we have plus, well, I times 2i is going to be 2i squared. Now make notes of this, minus 2i squared. Now we get to combining like terms. So 24 plus 8i minus 6i is going to leave us with 2i, and then minus 2i squared. Now remember right here we said I squared was equal to -1, right? I squared is equal to -1. So this is essentially this 2 times I squared, right? So you can rewrite it as 24 plus 2i minus 2 times -1. So 24 plus 2i plus 2. Now if we combine this and this, the 24 and the 2, where we get 26 plus 2i. This is going to be our final answer. Alright guys, now since we're on the topic of multiplying complex numbers, let's just drop a quick little note in there about something called complex conjugates. Now complex conjugate is something that's like this: a plus bi, this is going to be a factor, times a minus bi. Now this will always, no matter what, it will always output a real number. So our final answer will actually not be a complex number. Now let's actually try to solve this real quick to see why this is. So first, a times a is a squared minus a bi, right? Because we did a times a, and we did a times bi. Now we're going to do bi times a, so plus a bi, and we're going to do bi, we're going to do bi times bi. So it's going to be minus b squared times I squared. Now remember we said I squared is always equal to -1, right? So this is going to be equal to -1. So we're going to have a squared minus abi plus abi minus b squared times -1. Negative b squared times -1 will always output b squared. Now would you look at this? In the middle of this equation we have a minus abi plus abi. So that's like saying minus -1 plus 1, or -2 plus 2, because these are, plus 2, because these two are the same thing. This is x, this is also x. So negative x plus x cancels each other out. So now we have a squared, since we did negative b squared times negative 1, which is now a b squared, we have a squared plus b squared. Now, since we don't have any i's in here or anything like that, this will always output a real number. Alright guys, now for the moment that you guys have all been waiting for, we're going to try to solve a complex quadratic equation. So let's use the equation. Let me see what I could use. 4x squared minus 3x plus 5 is equal to 0. Okay, so let's see what we got in here, right? Now, our quadratic equation is that x is equal to negative b plus minus the square root of b squared minus 4 times a times c. Now, this whole term right here, we're actually going to divide it by 2a. Now, let's go back to our original equation over here. Our 2 is going to be 4. So 4 is going to be a. Negative 3 is going to be b. And 5 is going to be c. Now, we're going to plug this into our quadratic equation. So, x is going to be equal to negative, our b is negative 3. So, negative 3 plus minus the square root of, once again, b, this is where the imaginary part comes in. We have a negative 3 in here, which is going to get squared, minus 4 times 4 times 5. This whole thing is going, oh, this is supposed to be an equal sign. This whole thing is going to be, now, this is supposed to be a negative also, I'm sorry. This whole thing is going to be divided by 2 times 4. Now, let's start solving this. So let's start simplifying it, right? So, x is going to be equal to, we have a negative in front of a negative, it turns to a positive. So, x is going to be equal to 3 plus minus, negative 3 squared is going to give us 9, minus 4 times 4 is 16. 16 times 5, I believe that's like 90, right? Let's do the math. Or maybe 80? I don't know. It's not 90, right? 16 times 5. Okay, 16 times 5 is 80. Okay, so minus 80. I could have did it easier. 5 times 4, 20. 20 times 4, 80. That would have been an easier way to do it, but we're being bots, right? Square root goes right here. And now we draw a line. 2 times 4 is 8. So this is what we're left off with right now. So 9 minus 80, we're going to get x is equal to 3 plus minus 9 minus 80. I probably should have used better numbers for this. But 9 minus 80 is going to be negative 71 over 8. Now we have to write negative 70 and standard form. Now, negative 71 in standard form. Now, what I would do with negative 71, I would actually try to rewrite it if I can. I'm not sure if what numbers can I use. Yep, nope. We actually cannot use any numbers. So x is going to be equal to 3/8 plus minus, right, the square root of 71 over 8i. Now, we left square root of 71 like this because we actually cannot take the square root of 71. So we're going to leave it at square root of 71, but then we have to leave the I at the bottom of it. At the left of it. So our final answers, or our x's, would be x is equal to 3/8 plus 71 over 8i. And it will also be x is equal to 3/8 minus 71 over 8i. Thank you.